we are here at FDIC, and I'm here with Chris Robbins, who's our VP of Technology at Tersus Solutions. And I just kind of wanted to talk a little bit, Chris, about CO2, the process, what it looks like. So we're getting lots of questions as people are coming up, and firefighters, fire departments, ISPs are kind of asking, what is this new technology that's coming? They're hearing a lot about it. It's the new evolution of cleaning the PPE. And PPE, we're talking about from boots to helmets, right? Head to toe. What's going to work? Right now, we're using a water process. Can you tell us how CO2 might differ from that?
Great, yeah, great questions. CO2 is a very good solvent and a very good cleaning fluid that works very well with water. It works in conjunction with water. It's just another tool in the tool belt of cleaning gear and getting it decontaminated. The best way to think about CO2 is we have it under pressure, about 600 to 900 psi of pressure, and it works very similar to just your water washing machine. So it fills up with CO2, does the extraction, does the decontamination, and then we drain it out. The real big advantage, a couple of technical advantages of it, is the viscosity is very low, so it can pass through the gear very well and decontaminate at a very deep level, whereas water can't penetrate that far. And then we also collect all the contaminants on board through a distillation process and can dispose of those properly instead of sending them down the drain.
Great. Okay. So a couple questions about what you just said. Let's talk about how it passes through the gear. Do you have to separate the shells and the liners?
You don't. That's one big advantage of CO2.
Okay.
So we can keep everything together, and because of that viscosity and because of its penetration ability, it can penetrate through both layers simultaneously.
Oh, great.
Go through together.
Great. That saves some time then probably, not having to take apart, the gear. So
Correct.
Just throwing it in. Wonderful.
Yep, correct. We don't have to take gear apart, have that time. Gear can go in dry. Our process is about an hour and a half for a standard decontamination process.
Okay.
And for lithium decontamination, we were one of the first people that came up with the lithium decontamination cycle for EVs and scooters and everything else battery related. And that process takes about 2 hours of time.
Okay.
Garments go in dry, but what's great about CO2 is they come out dry as well.
That's
so
huge.
A little cool to the touch, which feels great in the summer, but it comes out dry, ready to wear, ready to go. So hour and a half later, you have clean gear.
Okay. So firefighter sends in his gear because he was exposed to lithium ion, or fire department sends in the gear. What does that look like as far as time frame to turn that back around for them, right? Because lithium ion is definitely a huge topic right now, right? How do you get it out of the gear? You don't want to buy new gear, right? It's from $3,000 to $5,000 for a set of new gear. If they send it to you, how long, what's that turnaround cycle time? And then what is the price associated with that?
Absolutely. So the way that we work with firefighters directly, or ISPs, or whoever wants to work with us, well, we have a couple different ways. Firefighters can send stuff directly to us from their departments. That turnaround time, depending on where you are, our standard turnaround time is 48 hours. So we can get it in, process it, and then get it back out.
Okay.
Some of the bigger times is just shipping. So shipping to and from our only location right now is in Denver, so we'll have to ship it to Denver. But that process is about 48 hours. We can get that gear turned around.
Okay, so if I'm in California, it's just going to take as long as it is to ship, and then you're going to clean it and ship it back. So we're looking at maybe a week total, maybe in shipping.
A week in time. Yep.
Okay. All right.
Especially anywhere on the West Coast.
Okay. So water wash doesn't cost a huge amount to get gear cleaned. And you do it once or twice a year, depending on these exposures. And we'll talk about that a little bit more and get into detail. But what is the cost on average if we're looking at CO2? I mean, sometimes we're hearing outrageous numbers, right? People are saying, it costs this much. What is the real cost?
The real cost of working directly with us, it's not that expensive. It's only about 20 to 30% higher than your standard water wash if you're going through an ISP. Working directly with us, we offer very competitive pricing that's not that much higher than water because we're not having to water wash it. Like we can get that. We don't have the disassembly process. We don't have a lot of labor there. CO2 can penetrate very deep again, so we can get that nice and clean and get that shipped back out.
Okay. So talk to us about, if we have an exposure, we've seen sewage and oil and paint and, lithium ion. And so when you're coming out of those contaminations and those situations, it's not just the turnout gear, right? It's not the pants and the coat. It's sometimes the boots or the helmet. What does that look like cleaning with CO2?
Yeah. Everything's that they go in with is contaminated at that point, right? It's from helmets, boots, gloves, hoods, even the SCBA masks. what's really fantastic about CO2 is it's very, very gentle with the gear. So it doesn't have a lot of that mechanical action beating up. It has some, but we're using more solvency power of the CO2. So we can literally put in all the gloves, which come out fantastic. Gloves come out very well. We've had stiff gloves come in that are just hard, and they come out nice and supple again. You can move the fingers.
Oh yeah, that's helpful when
that's great, right?
doing that job. Yeah.
The boots are also very good. They come out very nice and soft again. Obviously the turnout gear itself, but then the hoods we can put in. We have a very special helmet cycle. Doesn't rotate the basket, so it doesn't get damaged, but you can still get decontamination of the soft goods that are on the helmets, and then we can wipe the shell off to get it nice and looking clean. We've even done the SCBA masks. We can't do the regulators. We don't want to do that, so we take the regulators off. But the mask itself can go in.
Great. That's wonderful. It's just,
full head to toe.
Everything. Yeah. Full head to toe. It's great. Yeah. What a great solution. So let's talk a little bit about, you talked about agitation and basket rotation, and maybe you can talk a little bit and compare water wash and what an extractor does for degradation of the gear with agitation and what it runs at RPMs versus what we're running with CO2, and how you can help control that, and maybe some, I think you call them recipes that we might have. So let's talk about that a little bit.
Correct. So let's start with water wash first, man.
Okay.
So people are disassembling the gear, they're putting them in the extractors. With water, it will absorb some of that water, and it changes dimensionally. So, you fill up your extractor, and then the water gets in, and it squishes it all down and gets the fibers real close. As you're rotating it's constantly rubbing on each other, right? So it's constantly pulling the color out as well. So we've seen black garments turn gray. Everyone that's washed black knows it turns to gray eventually. But the rotations there, they typically rotate around 30 to 40 RPM.
Okay.
And then you go into the extraction. So one of the big things, since we're not drying, they say NFPA says you can't dry above a certain temperature. They do a high-speed extraction, and that's going to force all that water out and force that gear against the side, right? So now let's transfer over to CO2.
Okay.
CO2, since we don't have, since it can't pass through gear very well without, getting stuck. We don't have to have that high-speed extraction or a bigger rotational, bigger RPMs for the basket.
Okay.
So our RPMs typically range from about 20 to 30 RPM on a cycle. But what's interesting is our high-speed extraction, we call it high speed, is only 100 RPMs.
Oh, okay.
So, because that CO2, again, can just get out of the garments that much easier. And it doesn't...
How many times do you run that 100 RPM cycle?
It's only... So the portion of the cycle that has it is only about 2 minutes long.
Okay.
It's very short.
Very short compared to like a dry time.
6-7 minute extraction plus the dry time of the 24 hours of dry.
Yeah. Okay. All right. So we're saving time with no drying, right? So we're saving that amount of time. We're saving time that we're not separating the garments, which is huge.
Yep.
To me, it just sounds like a solution that can be used in multiple cases, but I know we really work with the specialized cleaning. Tell us some of the things you've seen that's come in that we've cleaned and been successful with, because I'm sure you've seen it all.
Great question. And firefighters, when we call them out, they get into everything, right? So anything and everything they can get into, they will get into. So some of the crazy examples we've seen CBD manufacturing facilities where gear comes out so sticky it sticks to the wall.
Oh my goodness!
And by the time the CO2 wash is done, it's ready to go back out.
Okay.
We've seen sewage before. We have seen bed bugs.
Okay.
The CO2 does great with bed bugs. It kills all 3 stages: eggs, larvae, and the adults, I guess.
Okay.
Can kill all 3 of them without any specialized treatment.
Okay.
We've seen the fire blankets come through, the big 26-foot by 19-foot fire blankets. Our machine is
used on lithium ion, right?
That's
with the
used
EV
to
cars.
cover the lithium ion cars. Our machine is big enough that we can actually fit that whole thing in the machine and get it washed.
Okay.
So we've seen those. We've just did some gear last week that they were at an auto recycling facility, and unfortunately, one of the firefighters fell into the pit where they drained the oil out and was covered up to his chest in oil. So we washed that, and it came out wonderful. It came out wonderful.
I don't know how he got in that situation and he fell in, but okay, all right. But we can clean it.
We can clean it. We'll take care of it.
Okay.
We will take care of it for them.
It's a huge cost savings, because otherwise, I mean, you're looking at replacing that gear. I mean, that's
Exactly.
thousands of dollars. So we're only 20 to 30% more than that, depending on what we're exposed to. So,
Exactly.
so we can do all of those specialized cleanings. Talk to me about just an advanced cleaning and how that differs and what we're seeing with the PAHs and CO2.
So what's great about CO2, from again another technical tidbit for
Yeah.
CO2, is the polarity is different than water. We have a non-polar molecule versus a polar molecule. So it does exactly what water is not good at without
Okay.
much detergents or anything. So that's why the PAHs, the SVOCs, um, all come out better in CO2. We're seeing upwards of 98, 99% removal rates of those carcinogens.
What's
Of
a
those,
typical carcinogen removal rate in water wash?
typically around 56 to 60%.
Okay, of the
So
PAHs.
we're
Okay.
seeing a very big increase in
Yeah,
the
it's huge.
amount of removal of the stuff you can't see.
Okay. So could you
So
water wash and CO2?
absolutely.
Okay.
That's what we really promote is it's just a tool to work with water. There are
Okay.
some things water is going to do very well with, especially around the construction materials. If there's any drywall, typically the blood stains. CO2 can kill the pathogens that are in the blood, but it won't remove the stain. So that comes out very well. Whereas CO2, you can then take all the hydrocarbons out, diesel, gas, anything get that high removal of VOCs. And what we really recommend is the best way to. We're always looking at the best way to clean the gear. How do we clean the gear the best for the firefighters, right?
Yeah.
And we really think that the best way is looking at water. Can we improve the water process and pair it with a CO2, and then you have the efficiencies of both, the effectiveness of both, and that's going to be the cleanest gear you can possibly get.
Okay. So for advanced cleaning, typically NFPA recommends that, you do this twice a year. As far as cleaning, we're seeing a wide range of departments that are doing once a year. They're doing in-station cleaning. They're doing after incident. What do you recommend, if you're doing that water wash and CO2, what is kind of your recommendation of what that looks like, combined, I guess? What's the ideal solution
So
for
I would
that?
say, per the NFPA standards,
Mhm.
the way I would look at it is let's look at water and CO2 for those annual cleanings.
Okay.
So twice a year, let's
Okay.
get that because that's going to get the gear the absolute cleanest twice a year, right? In between those cleanings, I would recommend looking at the contaminants that come in and saying, is this going to be more of a water, like water's going to be better at this, or CO2 going to be better at this?
Okay.
Because you don't want to, we want to keep the gear in life as long as we can. And what's great about CO2 is we've seen gear last longer. It just lasts longer because of the gentler process. So if we can go through CO2 only and remove the diesels and that stuff, great.
Yeah.
We don't have to beat it up with water. We can just do CO2.
Okay, good to know. Great. Okay. So let's go back to your recipes. So we know we have several different machines across the US right now.
Right.
And as we grow and expand and we get more machines, what does that look like as far as your recipes, right? Those specialized cleanings, sometimes I think that CO2 machine can be very intimidating and saying, it's huge, right? It's 10 by 10. It looks complicated, but I think in a way you've dumbed it down, right? We'll use the dumb word. You can make it Kindra proof here, right? Like I could run the machine. I can open the door. I can do it. So what does that look like with the recipes?
Yeah, absolutely. And we've intentionally designed the machines to be very user-friendly. We don't want them to be complicated. We don't need people with PhDs to come run the machine, right? We want it to be as simple as possible. So the machine is controlled via PLC and an HMI, just a human machine interface is what that stands for.
Okay.
So you're interfacing with the machine. And it's basically just a touchscreen on the front of the machine. And we have what we call, you refer to recipes.
Yes.
And that's exactly, it's just like cooking, right? You're following a recipe that the machine is laid out or you've laid out. As we get more contaminants, so our R&D hub is in Denver. We're building a lab there. We have our machine there, and we test all sorts of stuff that firefighters get into via CO2. And we also have water extractors there too, so it's a full lab and we can do anything. But specifically for the CO2, we can build these recipes as the gear comes in. We figure out the best process for it, what cycle parameters are needed, pressure, time, level, whatever it is.
Yeah.
And we develop that recipe. We then save the recipe. But what's great about the CO2 machines is we connect them all online and they all phone home, if you will, back to Denver. So as we develop a recipe and whatever we get, we can push those recipes out to whatever machine is out there and they can have the most up-to-date recipes and whatever we're working on throughout the United States at their fingertips and ability to go right there. So
wow.
As somebody in the East Coast comes up with this, as they see a certain contaminant come out, we can build a recipe on that, and then that's automatically given to all the machines. So even people on the West Coast, by the time they see that contaminant, they say, "Hey, we've already have a recipe for this. We've
Yeah,
already seen
we
it
can clean
because
it.
we haven't done it, but they have, and this
Yeah.
is how they did it."
Yeah. Okay.
So
All right. So that's great. Let's talk about the bones of the machine, right? Let's talk about the piping and all of that. So we understand the software seems pretty simple, right? That we can use an interface. Let's talk about the piping on it. When you go to actually do maintenance on the machine, what does that look like?
very good question, and that's one of the questions. Number one, almost the number one question we've got at FDIC is, what's the maintenance on this thing, right?
Yeah.
It does look very complicated. The maintenance we've intentionally designed to be very easy. So we're on generation 8 of the machine. Our co-founder, Sheldon Bray, Steve Matson, and myself are the designers and engineers of this and programmers.
So when people
As
call in, they can talk to
they
you.
talk
They're
directly
talking
to
to you
us,
guys.
to the
Yeah.
people that
Okay.
build them and program them and
Right.
design them.
Right. And you work with them all the
We
time. So
work
you
with
want
them
to
all
make
the
them
time.
easy.
Exactly. So we're on version 8 of the machine.
Okay.
And they're very easy to use. All the valves are on the side of the machine. It's very quick to change valves. The pump is on the back. The filters are right on the corner. So everything is accessible throughout the machine. And that just comes from experience of having to work on them in the field.
Yeah. Yeah.
Um,
Helpful, right? If you've got to do
very
the work,
helpful. Yeah.
then
We
you
do
make it
the work and
easier.
we say, what didn't we like? So
Yeah.
always the machine that's coming out is always the best one we've ever built because we always
Yep.
find little tweaks on it.
Yep.
But they're very serviceable. It's
Yeah.
very, very time effective, and there's not much that can go wrong. There's only 3 moving parts on it. It's a
Okay.
pump, it's a drive system to turn the basket, and valves. And that's it.
Okay.
Yeah.
Okay. Tell me if it gets a little bit more complicated and you've got to go out and service a machine. One, who's going to come out and service, and what does it look like from getting parts in and you coming out and servicing that? What does that look like?
Fantastic. So we have a couple different ways we work with people.
Okay.
We offer service plans with the machines, and depending on who they have on staff will depend on the plan they want to pick.
Mm-hmm.
So if they have a technical person on staff, somebody that fixes the trucks,
Yeah.
like, let's say,
Yeah.
very technical, doesn't mind getting their hands dirty,
Yeah.
they would sign up for a lower tier service plan. Still comes with parts. We provide all the parts for them and specialized tools.
Okay.
There are some big wrenches that are needed.
Yeah.
No special
imagine.
service tools, but
Okay.
just bigger.
Okay.
And we can come out once a year to kind of do an annual visit and say,
Okay.
how's the machine running? Here's, what are the cycle times looking like? How's the general shape of the machine? And just answering questions that they may have throughout the
Yeah.
year, because people come
Yeah.
up with questions.
Yeah.
We're always available. So that comes with remote access. So because the machines are online, you can phone me and I can get online with the machine and it's like I'm standing there with you. I can see the machine, I can see the back end programming, but I can see the HMI as if I'm standing right there with you and tell you what's going on.
Oh, that's great.
It's wonderful.
Sometimes it's like, right? I mean, it's something very simple.
Something
and
very
you can
simple.
just see that.
The air compressor wasn't on. Instead of getting on an airplane and flying out, I can just log in and be like, hey, your air compressor's not on. And
Yeah.
yes, you're right.
Yeah.
Turn it on and the machine's running again.
Yeah.
And then we have a second tier service plan. It's a little bit more intensive.
Okay.
We'll come out quarterly.
Okay.
And we'll do a lot more of the preventative maintenance for them.
Okay.
So that's going to be things like, changing filters as needed. Typically the filters last a month, but we can come out and change those.
Okay.
Changing valves, he's just also checking, but we'll come out more often. We'll come out every quarter instead of once a year.
Okay. So it seems like you're pretty flexible in working with people on making sure
Absolutely.
the machine lasts. But let's talk about how long the machine lasts, right? I mean, it's a big investment, right, for a machine. This is something that, an ISP is looking to purchase or a fire department's looking to purchase, it's a big investment.
It is.
Let's talk about quality of the machine, right?
Quality of the machine. So the machines are all designed, programmed, built, and assembled, everything right here in the United States.
Okay.
So the vessels are made in Wyoming. Great place to make vessels. We assemble them down in Mississippi. We have our R&D lab here in Denver. All the controls come out of Denver. We do all the program ourselves, and we ship them. Everything is done here in the United States.
Locally. Nice.
Locally. Yep. Nationally.
Yes. Yes.
But the quality of the machine, we also use all stainless steel. So all of our vessels are full stainless steel vessels to prevent corrosion or just rust, just keeping them as clean as possible. Mm-hmm. And the machines, we really designed them to be around 80,000 cycles useful life. So, and they probably are longer than that, to be honest.
Okay. All right. What's
so
80,000 cycles?
About 20 years.
Wow.
20 years of
Wow.
useful life out of the machines.
That's great.
Yeah.
Right. And stainless steel, so it's not going to
It's
rust.
not going to go anywhere.
Yeah, it's not. Yeah. Okay. Okay. So talk to me a little bit about the specs of machines. So you keep saying machines. Do we have multiple sizes? And then what do the specs look like on those machines?
We do. So we have two different sizes. We have we call them a 400 liter, and that's the size of the cleaning chamber itself.
Okay.
So we have a 400 liter and a 700 liter. The 400 liter is going to do about 3 to 5 sets of gear.
Okay.
The big machine is going to do anywhere from 8 to 12, just
Okay.
depending on the bulkiness and what's in there, right?
But when you're talking about head to toe, you could probably throw in some gloves or hoods with that, right?
Boots,
too.
gloves.
Okay.
You know, you can kind of throw it all in at
Okay.
once.
Okay.
Outside the helmets, we do the helmet separate.
Okay.
But those are the two sizes we offer.
Okay.
In terms of footprint and electric, they actually match each other. So we just use the same skid and base model, and we swap vessels out. So it's about a 10 by 9 foot footprint, 8 feet tall, so it can fit through 8-foot doors, 8-foot roll-up doors. We figured that was very important.
Yep. Yes.
And then they're about 25,000 pounds, so
Wow.
it's a little heavy to sit to place.
Right. You're not going to move this around daily, or you kind of need a
you
spot.
need a big forklift.
Okay.
It's not just picked up via
Right.
forklift. But so you need a big forklift to move them in, and then they sit down. We do have a outside chiller that goes with them.
Okay.
That comes with the machine. We just need to place it outside.
Okay.
And then we have a hot water heater it's not a boiler. It's a hot water heater. It just heats it up. So we go up to about 170 degrees Fahrenheit with the hot water. And another question we got a lot was, do you use water in the process? There's no water.
I was going to ask
at
that.
all.
There's
no water.
Yes.
So the water is only used to circulate to do our distillation process.
Okay.
It circulates through and then back to the boiler. So we're just using circulating to do our distillation process.
Okay.
Air compressor. Some people have it in stock. Some people have it on air site, but we can also just use.
Talk to me about the air compressor. What are the requirements of the air compressor? I mean, is it mass capacity, right? I mean, is it huge? Do we need a large industrial one?
We don't need a large industrial one, surprisingly. So the compressed air, from a technical standpoint, only is used to rotate valves. Very small amounts of air. Typically need about 80 to 110 psi of pressure, which is very standard amongst all standard air compressors, certainly industrial ones. And the flow rate's very low, somewhere between 2 and 3 cubic feet per minute. So it's almost just an air compressor you could buy from Home Depot. Okay,
pretty simple.
Or Lowe's.
Okay, all right, great. Okay, all right. Let's back up and talk about, if you're bringing the machine in, right, and you're delivering the machine, does it look like you've got to bring it in piece by piece and put it together? Or I'm just envisioning this might be a little difficult for people. How many weeks are you there, right?
Yeah, so
site?
We do a lot of coordination with the customers and with contractors before we even get the machine there. Okay. So when somebody buys a machine, we work with them to say, here's what, because we've installed a lot of these.
Yeah.
So we're pretty pros at it.
Yeah.
We start with the CO2 supply. We set up the CO2 supplier. All of our CO2 is recycled CO2. We forgot to mention that. It comes from.
We'll talk about sustainability here in a minute.
We'll get that, but we'll get to that.
We'll circle that back around.
When we move these things in, we work with them. So it typically comes, the machine breaks up into 2 skids. We move them in with the big forklifts again.
Yeah.
Set them and place them down.
Okay.
Then we put the ancillary equipment, so the hot water heater and chiller.
Okay.
At that point, we'll then make the final connection. So it's during this whole time we've been working with the customer and contractors, getting all the pipe work in place. So by the time machine shows up, it's within 5 feet of the machine.
Okay.
So then they just come, make the final connections, and we can charge everything up and start filling the machine at that point.
Great. So one question, working with contractors, is that included in the cost of the machine?
It's not. So the installation costs and the contractors themselves are secured by the customer. Typically, depending on what's needed, it's going to be anywhere from about $50,000 to $100,000, maybe more depending on where you are in the country, just how much, how many laws, regulations there are around stuff.
Yeah.
But so that is separate from the machine cost.
But your time in working with the contractors and setting up, that's included.
Yep, that's included.
Perfect. Okay. So we've installed the machine now. What does it look like afterwards? What does your training look like? And even back up before that, we've installed the machine, it's sitting there. How long until it's actually running? And what does that look like after that? Do we do test cycles? And then, I'm sure you guys are there on site, but what does that look like as far as training and getting that person trained?
Great question. So the machine, even before it leaves our facility, has been running. We have an extensive QC check and functional test. So the machines have already ran cycles by the time they show up at your door. So we'll install the machine, get it going. Typically, that process takes a week.
Okay.
So once all the pipe work's there, the machine sits down, the contractor will come do all the rest of the
Yeah.
piping. We can start the machine up at that point. So that process to get it filled into the first cycle on site is about a week.
Okay.
After that, we will then train. So we have operator training, and we also have maintenance training. We'll typically stay on site for about 2 weeks with one of our associates or techs, and they will do all the training for the machine.
Great.
So they'll say, how do you run it? How do you open the door? We also have a full list of maintenance manuals, SOPs, and operating manuals that come with the machine. And then you always have access to me or Steve or Sheldon to how do we work this thing.
I'm impressed. A week, you can get this thing running in a week, and it's up and it's there. So
yep. And they can start running cycles that second week.
Amazing.
And it typically starts with us training them, right? So what we like to do is say, bring your gear, let's start running cycles. Let's start running cycles on it, and we can actually use those for training cycles as actual cycles.
Yeah. Great. Okay. So let's circle back way back when we were kind of talking. You were talking about, the tank that all the contaminants go to, right? It's a closed loop system, if I understand it. So everything's going to be enclosed and you're just cycling that out. Let's talk about sustainability a little bit. So we have those contaminants it's collecting. Let's also talk about the CO2 that we're using, where we get that, how that goes through the system, and any other sustainability points that you think might be comparable to water wash.
Absolutely. So let's start with the contaminants. That was your first question.
Yeah.
The contaminants are all from that distillation process, all end up in what we call just a sludge tank.
Okay.
And what that does is that allows us to get the sludge out of the still into a 55-gallon drum. So it just drains into there.
Okay.
That drum has to be replaced about every 6 to 7 months, depending on the cycle, or depending on how much you use it.
Right.
And
exposures, right? Specialized cleaning. If you're in California seeing lithium ion compared to somewhere else, you might not be seeing a bunch. Okay.
Exactly. So that drum will be swapped out. It's an easy process to swap it out. And then we would just work with an environmental company at that point to dispose of it properly.
Okay.
So instead of having the washers drain down into the sewage, into the wastewater systems, we can collect that all and dispose of it properly.
Great.
So a company will come and pick that drum up and get rid of it for us.
Wonderful.
Same with
Great
the filters.
Sustainability point.
Great sustainability. Now, regarding the CO2, I know I touched on this before.
Yeah.
Is all the CO2 is actually recycled CO2. So we really work with the suppliers of CO2, and there's multiple suppliers. Anywhere that has soda has CO2. So it's either some of the bigger companies, Airgas or Praxair is what people know, but there's a lot of just smaller companies that just supply CO2 gas.
Yeah.
We use beverage grade CO2. It's 99% CO2 purity, and it's all recycled. So for example, like our Denver facility, we get all of that from an ethanol plant down the street. So they take it out of the ethanol smokestacks and reuse it in our machine. So we're not generating CO2 to do that. But we're also offsetting water during that time, right? So we're not using water, which is typically going to be around 100 to 200 gallons of water for an industrial laundry piece of equipment.
Yeah.
So we offset all of that. Again, the wastewater processing time. But when we look at the electrical efficiencies as well. So we've done a big study. I'm happy to send it to anybody that wants to read 300 pages. But we've done
I don't know. Some of the tech people might.
We've done a big study around water efficiency and CO2 efficiency. And that was with the United States Navy that we did that. That's actually where it all started. It's from the Navy base. But outside that, the electrical efficiency and the energy efficiency of the CO2 was about half of what it was when you include a washer and a dryer.
Wow.
So the energy requirements are about half of what it was with that.
That's great.
It's wonderful.
Okay. So let's talk about other things besides fire gear, because I'm just sitting here and thinking there's probably other things you can clean with CO2.
Absolutely.
And from a government perspective or a city or municipality perspective, there's probably other things we can throw in there, and maybe it's more of a solution for a community to use. So what have you had experience with?
A lot of the governments that would buy this, and especially firefighters, they're government entities. So we can partner with other services around in the government. So the first one that comes to mind is, hey, let's talk to the police force. They have ballistic vests. We have clean ballistic vests with CO2. So we can, again, with that viscosity, it can get down through the carrier and start cleaning out the Kevlar panels that are underneath. So you take that body oil out, the sweat, and it just smells better and feels better for the officers responding to calls. So that's a great one. Sanitation workers, their uniforms that they use, we can clean those. Any type of oil field work or energy we can clean very well. We've done
Okay.
a lot of obviously we do a lot of Nomex and fire retardant
Yes.
stuff. So we take all of that out, or we can clean that without harming the properties of the fire the fire properties.
Okay.
We can also work with things outside of just the government entities. We've also done down in wool and leather. So a
Oh,
lot of the
okay.
a lot of the carriers that firefighters use for just accessories, right? Like
Yeah.
walkie-talkie holders
Oh,
and
yeah.
flashlights. So a
Yeah.
lot of that stuff's leather, and they
Yeah.
think they can't wash it because leather doesn't do well in water, right?
Right. Which it doesn't.
It doesn't. It
Right.
stiffens
That's,
up and
yeah.
gets hard.
Yeah.
But with CO2, we can clean that stuff and decontaminate it for them. So everybody loves it's a natural resource. It's a lot better,
Yeah.
and it just holds up better. People love it,
Yeah.
but they can't wash it. So we are offering a process for them
Okay.
to wash it.
What about anything from the health industry? I mean, are we seeing like X-ray vests or anything? Can we do any of that, or is there anything we can't do?
We can. So we can do X-ray vests. We can do. We've done clean room gear. We can do some medical stuff. A lot of the medical stuff comes out better because it's more water-based,
Okay.
water-based items. But we can help decontaminate that stuff
Okay.
without the need for radiation or harsh chemicals to get
Yeah.
that stuff clean. CO2 can typically get a sanitation level of about a log 5 reduction
Okay.
just with CO2. We've done log 7 with chemistry through a clean room project we did. That's typically not required for a lot of
Right. That's
everyday
good to know.
stuff.
Okay. Okay. Great. So sometimes I think people are fed this thing that CO2 solves all problems and can do anything, right?
We've
I know
heard that
you've
many times.
Yeah, right. I know you've probably run into things that doesn't work well in CO2. Can you be honest with us and tell us what it does not work well on right now, or maybe what we're looking to advance in the future, still testing?
Sure. Some of the things that we're looking to advance, in terms of like the fire gear, heavy metals have always been a problem. It's a problem with water. It's a problem with CO2. So we're really working to get both of those levels up. So what combination of stuff do we need to do to get that up? Water does very well with any of the oil-based, or the water-based stuff. So that's going to be like blood stains, grass stains, a lot of stuff like that, like just stuff you would, food stains.
Right.
CO2 on the opposite does better with the oil-based stuff, the stuff water doesn't do, right?
Yes.
We add detergents to water to make it go towards oil. CO2 just does it naturally. So
Yeah.
all of that stuff, think of like, pHs, VOCs are the big ones. We do very well with those. Biological, we do very well with. Gasoline, diesel, any hydrocarbon is great. A lot of solvent-based, fertilizers and stuff like that can all be taken out with CO2. Whereas we're going to need detergency to go more towards the water-based stuff.
Right. Right.
So,
what about anything you were talking about the different straps and things? An SCBA mask, right? Not the regulators. What about electronics?
We have done electronics before, and it does work.
Okay.
One thing we do need to take out is the batteries. Can't go in with batteries.
Makes sense.
So some of the air pack carriers, they'll have a built-in battery.
Yep.
We haven't done that, so we're working on, can we modify parameters in the machine to do more of that stuff? We can do that. Going back to your question about what material CO2 doesn't do well with, soft rubbers. Soft rubbers don't do very well.
Weird.
The reason being is CO2 can get in, but when we decompress the machine, all of a sudden it starts to bubble. You'll see some bubbles coming up. And it's typically on softer rubbers. So think of like the rubber boots that they wear.
Yes.
We typically won't do those just because of that specific problem.
All right, good to know. Hey, I'm glad you're honest. So let's talk about Tersus is very innovative. You guys are, and you're hearing lots of feedback from all of the different firefighters here at FDIC, and kind of taking into account the next level, the next step, right?
Absolutely.
So I know you're super passionate about this project.
Wheels are already turning.
Let's dive in. Let's talk about the lab that Tersus is working on.
Yep, the lab is one of the newer things that we're working on, and we're very excited about it and offering it to really anybody in the fire industry. So what we're working on is being able to do testing, any type of testing that the standard, like the big national labs that do NFPA testing can do, right? So we've got
Intertech
UL. Or UL.
Okay.
We're taking the 1851 standard, soon to be 1850, and looking at what can we do. We need to test this stuff, and we want to be able to test it in house. And one of the big feedbacks we've gotten from this show is the lab The lab scene is not great right now
Mm-hmm.
because they're changing standards. Everybody's bogged down, and it's just expensive, right?
Mm-hmm.
So it's long leads and it's expensive.
Mm-hmm.
Well, being innovators and wanting to do R&D, that doesn't work for me.
Yeah.
I want to go
Right.
fast. I like to
Right.
go fast
Right.
and break things sometimes.
Yes.
So we're working. We've got an ICP mass spectrometer coming in that's
Okay.
going to test our heavy metals
Okay.
and look at all that. We've got a gas chromatography slash mass spectrometry for VOCs, PAHs, anything organic,
Okay.
and then we're also working on the biologicals.
Okay.
Outside of that, so that's just the 1851 standard.
Sure.
So we're also looking at or going upstream for some of the fabrics as well. So we're looking at a flame cabinet to making sure that as we develop CO2 detergents and we do water detergents, because we talked about they couple together so well.
Mm-hmm.
Like, let's also look at the water. Like, let's build detergents for them. So making sure all that stuff can wash out, and that's going to be a big thing with the flame cabinet, is making sure that's not flammable. We're not leaving flammable stuff on the gear. We want gear that comes back, one, doesn't smell like anything, because that's going to be the cleanest. So if it comes back smelling like oranges or fresh meadow or chemicals, we don't want that, right? We don't want the smoke smell.
Right. Right. But so our brains are trained that way, right? So we need to get it back with nothing. We want to smell nothing.
It should just come out of the box with nothing.
Yes.
Because even that fresh metal scent or that orange scent, while it's usually, it covers up some the smoke smell.
Yeah.
And if you smell the orange, it's coming off the gear.
Yeah.
Right? So we don't want that. So
yeah,
that's gonna be the big thing with the flame cabinet, is making sure things aren't left on there that are flammable.
Okay.
We also got photospectrometry that we're going to be using. So that's going to look at color differences. So as we do durability testing, what's the color difference and how many cycles do we start seeing that color? So with CO2, again, we talked about that earlier, the color difference with CO2 is usually negligible.
Yes.
We can't really see it with our naked eye. We can see it with the spectrometer, but not our naked eye. Water, you can see after about 10 cycles, it starts to gray. It starts to lose that color. We're also getting the retro reflectivity tester. Worked with talked to a company here, and they gave me the model number of one, so we're buying that.
Great.
So we're staffing the whole lab to not only just do 1851, but looking at the whole industry as a whole.
Wow.
Like, can we do all of this? And we really want to offer it. You talk about innovation.
Yeah.
There are so many people that want to innovate in this area that it's either just a time or specifically a cost. Like, they can't go. You can't do 10 tests at thousands of dollars for very long.
Yeah.
So we want to offer services that can look at that stuff and make it better for the innovators to come and innovate in this space.
Yeah.
See how well we can do.
Yeah.
Like, raise everything up, raise the standards up, like raise the percentages up, because that's what we want. We want the cleanest gear for every firefighter on the market.
That's what the industry wants too. So we're hearing you don't just want that 50%, 60%. You're demanding higher, and so we're bringing that to the table. So
and there's been a lot of talk about how it affects the firefighters, right? So how the health consequences of having this stuff has been drilled in their heads, and we're getting it now, right? We know it. Let's raise those standards. Let's get them up.
Yeah,
let's go.
Yeah, agreed. Well, Chris, it has been wonderful chatting with you. Is there anything else you want to tell us about, or that you want to touch on, as far as just the industry and what you're seeing? This is your first time at FDIC.
First time at FDIC. So, it was quite an experience from the other trade shows we've been to, but it's just what I've noticed about firefighters in general is really down to earth people. They just get it.
Yeah.
Like, they just get, hey, we want better gear, we want cleaner gear. However we get there is fine, but they're just so excited to see the innovation in the space and saying, like, hey, we're not just using 50-year-old water washers anymore. We're actually innovating with something, right? And they're excited about that. They want to be on the forefront of that.
Yes.
Just like I see so many companies here that are doing such innovative things. It was so much fun to walk around and just see all the trucks and all the new innovations going on in space. And my mind was just like, wow, we can do, like, there's so many good people here. And the firefighters, I love the firefighter market. I just love the people here. Yes. And we want to do what's best for the people that protect us. Yes. We want to protect the people that protect us.
Agreed.
That's what
we're here for.
Our mission is. So we're going to do that as best we can.
Great. Well, thanks for talking today, Chris. Appreciate it.
Thank you,
Kindra. I learned
Kindra.
a ton. So thank you. Hopefully you guys did too.
Happy FDIC.